BigQuery has a very nice function called generateInt, which returns an integer now from an LLM model. And this is something you should know because it's amazing. And the best part is that your stakeholder will say like, that's so nice. Where's the data guy? And then everyone is cheering, applauding. There's fireworks going off in the background, and you walk into your lunch break. And at least that's in my head. How this will work out. But in general, we will go over the AI function generate integer that will basically call an LLM and then ask to give us some numbers. We have two scenarios that we go over. I show you how to set it up and how everything's stitched together. So let's go. So I have my table here, which is a table called customer by city. We have a customer ID, we have a city, we have a province. This is not always filled properly, so it's good that we also have these examples. We have a country, and then overall we have 645,000 entries here. And of course I have it on customer ID. What we would now like to do is basically to create a function that does call the generate integer. So in order for you to also follow me, we have a guest profile here, and then let's say we need to open our function that we want to look at. In this case, generateInt. You can find it in the generative AI functions, and there are a ton of cool functions that we can explore. In this case, we are looking at the generateInt. I've already looked at a couple of other functions. You can see it in one of the videos as well. So generateInt does something like this. So for example, we have this called generateInt, give it a prompt. So it says, okay, can you give me an article from 1 to 5, very positive or very negative or very positive? And then you can ask it the model, and it gives you an output. And the output we can probably see in examples. Here it's like, okay, we have a city. We say, what's the population of city? And then we say this endpoint. And then it gives us the results of those cities. And that's what we are going to rebuild with a couple of understanding topics in between. So coming back to our original task. So we have this customer by city, and like I said, we have a lot of like entries here already. So the first thing is we don't want to call the AI for repeated entries, right? So meaning also there are a couple of unique entries here. There's also, okay, we have Albertville for 4 customers at least in this data set. So the first thing that we want to do is to reduce our amount of data that we ask, because the data is the same, meaning that in our case, every time we call the LLM, it of course costs us something, and we want to avoid calling like multiple times. In this case, the first thing that we want to do is like we go down by, we just say city, province, and country, and just for us to see how group by all, how many entries we still have. We're down to 52,000 entries, so that's good already, like a reduction of 10 times the original data set. So that's already very beneficial for our data. So I say also I want to trim the city, trim the province. Trim basically says if there's any like space in between at the beginning or at the end. I just also say as city, and now what is also interesting is we have like uppercase, lowercase. So we will cast everything to lowercase, lower, and another lower. Say group by all. Let's see how many entries we still have. So we're down to 28,000 entries. You probably can't see it in the screen right now, but it's almost 29,000 entries. So with this, we can now wrap it around. Say with main as up. We do a CTE around this, and then now we can start calling the function. And in our case, going back to the documentation, we have the generateInt, prompt, endpoint, model params, and connection ID and request type. And prompt is pretty obvious. This is what we are feeding to the model. The endpoint is 2 options we have here, 2 options that we have here. Endpoint is either Gemini Flashlight currently or Gemini Flash. Flashlight is a bit less expensive. It's basically the LLM that we're calling. You can also configure your own endpoints, but for our purpose of what we're doing, it's quite nice. We also have model params, connection ID, and request type. So let's go to model params. Model params is a JSON that we can feed with additional options for the model. And you see already there's an example here. There's an example here where we say like, okay, we would like to have model params of generate config, thinking config, thinking budget equals 0. And of course, like this seems like very arbitrary config value. But if you go to arguments here again, and we go to the model params, you see that model params conform to generate content request body format. So if we click on this and open our part here, we see that request body, we have tools, tool config, safety, with generate config. And if we go back to our example, it's part of the generate config, thinking budget. So generate config, we click on this one. And here are a couple of things that we can already use. So for example, something that might be familiar is top P, temperature, and here our thingy config. Let's just go over if you have max output tokens, also interesting. For our function, that since we just want to have an integer, I think we don't need to fine tune this massively. But you see also thingy config, then we can go to the entry of thingy config. And then you see like thinking budget, and it's optional the token budget for model thinking process. The model will make the best effort to stay within the budget, blah, 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 blah. So this is more of like how many tokens we want to have for the model to, before it basically starts doing something, right? So we are like in the thinking models, because even though we have two models here, one being Gemini Flashlight and Gemini Flash, they both are thinking models. So meaning that whatever we ask for them, they will iterate over the input. Anyways, so going back to our original topic. So we have this, and for our case, let's just limit this by 100, so that we are not going completely overboard with everything. And we want to do the following. So I have my my data now, and I could say, okay, I of course want to select everything here, and then I would like to call an AI function, which is called generate int, right? So that's nothing surprising. And now I can say, what is the population of those cities? Right, so I can now also concat everything city. Oh, yeah, we do it like this: city up. Say city here. Oh, see, I have to also change it here. Province. And we have to say country as well here. Country. City. Then we just concatenate everything here together. As for readability, we go up. Then we say here we also need to remove this one. Province. Province is the next. Province. And we say country. Nice. So that's our prompt. Then we can give it the next argument, which is the endpoint that we want to use. And in this case, assigning always with like this kind of like equal sign and whatever. It's the bigger closing bracket. Bigger sign, depending on how you see it. But this we can just like also use one of our models, which, if you remember, is going to be Gemini Flashlight, because we don't ask for something that needs a lot of thinking here. We say, okay, this is our model. Oh. And with this, we should be already ready to ask. And let's see what it returns. So first things first, we have the cities, and then we have response and the status. And you see like response is quite big. We have different candidates. We should have the result here as well somewhere. Result, parts, text, answer, model version, candidate tokens. Let's just look at the result specifically. We just put dot result at the end, right? And it should also work. Let's see. And now, of course, we are calling the LLM twice, which we should avoid ideally. So, yeah, see, so results. And of course, we can call it like as population. And now we have the population of each of those cities. And like, for example, if you would like to get like your total addressable market or whatever for a specific city, that's quite nice. It's also nice to basically look at market share calculations, so all the kind of management KPIs that we all love to do. Quite nice. And if you consider like how little effort we had just for doing this, that's already amazing. The other part I would like to show you is you can also call this with a different prompt, right? In our case, it's like we can also think about, let's do, what is the temperature today? Oh, right, we don't remove everything because I don't want to rewrite. What is today's temperature of those cities, right? So very simple prompting. We're not doing like very, very sophisticated stuff here. So by doing this, we also ask the LLM. And of course, like our column is not population anymore, but if you can see it, so we now have like the temperatures in Fahrenheit. Does that make sense? Alabama, 24 Fahrenheit? That does not look correct. Right, in Fahrenheit. Let's see. Of course, like it's an LLM, we have to always verify what we're doing here. Oh, yeah, so this looks much better in Fahrenheit. It's of course not population anymore, but we have 30, 38, 78, 78, and so on and so on. And we have different kind of temperatures, of course, for these days. And just for the sake of it, looking at our origin table again, we also have a last purchase timestamp. So in our case, I could just say we could actually just do last date, last purchase date as purchase date, or because I don't believe that the LLM will ask for the specific timestamp, so we could just say what is the average temperature Fahrenheit on, let's do on, we do purchase date, and then we say of course what's more the average temperature. And I'm missing here something. Nice. Okay, we still ask purchase date. And we can also ask this now, also on another request to the LLM, which will incur cost. And then we have the dates, and let's just check for a cold day. Yeah, a cold day in Edison, Alabama on the 20th, on the 9th of January 2020 was 46 degrees Fahrenheit. I believe that that's true. We can also look this up, but for our purposes, this goes beyond the scope of what we want to do. So that's quite nice. What we should also take into account is that we can now basically do a lot of stuff that we couldn't do otherwise, right? So these functions are very, very difficult to do before. And of course you can call an LLM before. It's just like now it's a native function. And the thing is that you also, with generate int, which is as of currently it's still in preview, with generate int you get like a deterministic int value, right? Which is quite nice. What I need to say as well is, like, of course you can also do this with images. You can do we have an example for images. So you just have to do the object ref to the image, and then you can ask, for example, is this a cat? Is this a dog? Is this like a person wearing a hat or whatsoever? Right? There are a couple of sections about like managing inference costs, but of course you should always do less complex queries. And limit your data set, right? So that's then there's also discount token functions, which you can see like how many tokens this might use. And of course it doesn't apply for thinking tokens, because thinking tokens are not something that BigQuery can estimate. You can also do provisioning through your own model, and so on and so on. But in general, that's quite nice. Like, honestly, having these kind of functions inside BigQuery makes you so much more capable of like getting data that is something that you would normally not have in your backend or in your databases or whatsoever. So with this, you can also say, like, for example, let's just for our case call it temperature to make the point properly. In this case, we could say like, is there a specific pattern? Do people buy more when it's colder? Do people buy more when it's warmer? These like fancy metrics that actually no one really looks at because they don't necessarily drive the business. But it's nice to know. And of course, if you know, you can act on it. And with this like functionality, this is quite nice, right? So we're in a realm now where we can like arbitrarily pull data and enrich our tables with just a function call in BigQuery, right? So that would take normally like data engineering approaches. And with this being said, if you want to see more BigQuery stuff, if you want to see more marketing tech topics, please give me a like, subscribe to the channel. Thank you for staying so long, of course, and hopefully see you soon. Have a good one. Bye-bye.